Hello everyone, my name is Nura Farahani Binti Nasir and I will be explaining the question number 1 and the conclusion.
Assalamualaikum everyone. My name is Sharifah Hishira Fariha binti Said Zalsha and I'll be explaining the question number 2.
Hi, my name is Muhammad Adam and I'm going to explain question number 3.
My name is Muhammad Azim bin Muhammad Fazil and I'm doing question 4.
To start with, I will explain the meaning of differentiation and the techniques used in differentiation. Differentiation is a process in calculus that measures how a quantity changes with respect to another quantity. In simple words, it helps us find the rate of change or the slope of a curve at a certain point. The result of differentiation is called the derivatives. The basic formula for the differentiation is f prime x equals to limit of h approaching to 0, f times x plus h minus fx over h. There are several techniques of differentiation. The first one being is the derivatives of constant, linear, and power functions. Second, we have the derivatives of sums and differences. Next, the product rule. And afterwards, we have the quotient rule. And the fifth one is derivatives of trigonometric, exponential, and logarithmic functions. And lastly, we have the chain rule. So that will be all from me. Thank you.
The second question that is given is find dy dx for the following function. The first function that is given are y equal to ln x squared tan x minus 3. For this, we're going to use product rule. What are product rule? Product rule are dy over dx equal to vu prime plus uv prime. Well, first we're going to find du. U are ln x squared. We're going to differentiate this so that we can get u prime equal to u ln x. Well, ln x is going to become 1 over x. We're going to be combining this so that we can get 2 over x. Next, we're going to find v. V are tan x minus 3. Well, differentiate this so that we can get sec squared x minus 3. Well, we're going to differentiate the inside again so that we can get 1. By combining this so that we can get v prime equal to sec squared x minus 3. So, the final answer for this question is dy over dx equal to 2 over x tan x minus 3 plus ln x squared sec squared x minus 3. That's the final answer for this question. The next following function that is given is y equal to x squared plus 1 over cos x. For this, we're going to use the quotient rule. So, first of all, I'm going to clarify that the output part is going to become u and the bottom part is going to become v. Well, what are quotient rule? Quotient rule are dy over dx equal to vu prime minus uv prime over v squared. Well, first of all, we're going to find du. U are x squared plus 1. By differentiating this, we can get u prime that is 2x. Next, we're going to find the v. V are cos x. By differentiating this, we can get v prime that is negative sine x. By using the quotient rule, we can get cos x times 2x minus x squared plus 1 times with negative sine x over cos x squared. Well, we can simplify this so that we can get 2x cos x plus x squared plus 1 times with sine x over cos x squared. Well, we can separate this now so that we can get 2x cos x over cos x squared plus with x squared plus 1 sine x over cos x squared. Well, we can simplify it even further by crossing out the cos in the 2x cos x so that we can get 2x over cos x plus x squared plus 1 times with sine x over cos x squared. Well, we can convert this using the trigonometry function so that 1 over cos x can become sec x and sine x plus cos x can become tan x. So, the final answer for this question is dy over dx equal to 2x sec x plus x squared plus 1 times with sec x tan x. And that's the final answer for this question.
For question 3, we will differentiate both sides with respect to x. Starting with our first term, the derivative of ln y is simply 1 over y, and because of the chain rule, we will multiply it by dy over dx. Next, we need to differentiate cos square x squared plus exponent y. To make it easier, let's rewrite it with the exponent on the outside, so we can see the layers clearly. First layer, bring down the power of 2 using the power rule, leaving the inside untouched. Second layer, multiply by the derivative of cosine, which is negative sign. Third layer, set up the derivative of the innermost angle. We can clean up the front using the double angle identity. Now, differentiate the inside, x squared becomes 2x and exponent y becomes exponent y dy over dx. Distribute the negative sign through so that the dy over dx part is completely split from the rest. Moving to the right side of the equation, we have 2xy, which requires the product rule. Let's set our parts. V equals to 2x, making v prime equals to 2, and u equals to y, making u prime equals to dy over dx. Now, let's line up our entire differentiated equation. On the left, we have our terms from step 1 and step 2, and on the right, our result from step 3. Our goal now is to isolate dy over dx. To do that, let's move all the terms from containing dy over dx to the left side and move the non-dy over dx term to the right side. With all the dy over dx term gathered on the left side, we can factor dy over dx out of the entire expression. To solve the dy over dx completely, we divide both sides by this entire group expression. This gives us a big fraction for our derivative. To get rid of that 1 over y fraction inside our denominator, let's multiply both the numerator and denominator by y. Distributing the y gives us our clean final answer.
For our final question, we need to estimate the value of 8.02 square minus 1 over the cube root of 8.02 using linear approximation. Rounded to 2 decimal place, this technique allows us to approximate messy decimals by using a nearby whole number that is easy to calculate. Step 1 is to turn our problem into a formula, fs by replacing 8.02 with the variable x. This gives us fs equal x squared minus 1 over the cube root of x. To help us find the slope later, we can also write this using an exponent. Step 2 is to find the derivative, which tells us the slope of our formula. By taking the derivative, we get a new formula, 2x plus 1 over 3 times x to the power of 4 thirds. This will tell us exactly how fast our value change near 8. Step 3 is to find our distance from 8, known as delta x. Our target is 8.02 and our starting point is 8. Subtract the 2 give us a tiny distance of 0.02. Step 4 is to plug 8 into our formulas. The original formulas give us 63.5. The slope formula gives us 16.02. Next, we multiply those slope by our tiny distance 0.02, which gives us 0.32. Finally, we add that 63.5, giving us our final estimate 63.82. This concludes our calculation, showing how linear approximation yields highly accurate estimate using basic derivative. Thank you.
In conclusion, our presentation shows that calculus is much more than just numbers on a page. It is the map of how our world moves and changes. From finding the fastest route on our daily commute using GPS to helping businesses calculate their daily profits, differentiation allows us to break down complex, real-world situations into predictable steps. Our main takeaway is that by understanding the rate at which things changes, we gain the tools to make smarter, data-driven decisions every single day. Thank you for your time.